Okay, today I'm going to talk to you about nuclear equations. So what a nuclear equation is when a radioactive element undergoes nuclear decay, it means the nucleus is breaking down. And different particles can be emitted, so different particles can be given off during this decay. So we need to know about 4 different types of decay and how to do the equation for each one. So to begin with, we are going to look at alpha decay. So for each one, if we know what the particle is, then we could figure out the equation. So an alpha particle is like this. It's made of 2 protons and 2 neutrons. Remember, this bottom number, the atomic number, also sometimes called the proton number, tells the number of protons. This top number, the mass number, tells us the number of protons and neutrons. So the format of nuclear equations is always like this. So let's say we're trying to figure out the equation for the alpha decay of radon. So we're given this. Now, as long as we know this particle, we need to remember this alpha particle, then we could figure out the equation, because there's always a rule. The rule is we start off with our element that's decaying, breaking down, and then we write the new element that's been formed and the particle that's been emitted, given off. So we're going to come back to figure out what this is in a second. But first of all, I'm going to write down my alpha particle, which is this. Now, the golden rule, the way to get all of these different equations to work, is we must remember that the total mass and atomic numbers must be equal on both sides. So each time we're just thinking, this number here on top, this mass number here, must add up to the sum of these 2 mass numbers. And the atomic number at the bottom must add up to the sum of these 2 atomic numbers. So let's have a quick look at radon. So radon has got atomic mass of 226 and the alpha particle has got 4, which means, because we've lost 4 protons and neutrons, it's now down to 222. The bottom one, we started off with 88, we've lost 2, so therefore it must be 86. Now, we no longer have radon because the proton number have changed, the atomic number has changed. So what we need to do to figure out what we now have is we need to use a periodic table. So here we could see there's our radon with 88, but we've lost 2 protons. So we need to count back 2. There's 86. We now have radon, Rn. Okay, next up, we need to look at this, which is beta minus decay. So a beta, basically what we're giving off is this thing here, which is basically the equivalent of an electron. So, again, let's imagine we had to do the equation, the nuclear equation for the radioactive decay of this carbon isotope. So again, we start off with carbon. We show that it's being broken down, it's decaying. I know that I'm producing my beta minus particle. So now, again, just as before, I just need to make sure the top and the bottom add up on both sides. So 14 on the top, there's 0 here, so that must be 14 as well, because 14 plus 0 is 14. Now on this side, something plus minus 1 is 6. So that there is going to be a 7, because 7 plus minus 1 is 6. So again, my proton number has changed, so I must have a different element. So I started off with 6, I now have 7, so I have formed nitrogen. Now, in beta minus decay, a neutron changes into a proton and an electron. So that's why the mass number doesn't change. Okay, next up, what I have next is positron emission. So what a positron is it has the same mass as an electron, but it's just a positive particle rather than a negative particle. So let's imagine I had the nuclear decay of this fluorine isotope. So it starts like this. Again, I show my arrow. I know I need to learn each of these particles, because if I do, then I could figure out the rest of the equation. So for this one here, on top, it's going to be 18, because 18 plus 0 is 18. On the bottom, something plus 1 is 9. So it's going to be an 8 on the bottom. Again, my atomic number is changed, so I'm going to have a look on here what 8 is. It's oxygen. So we formed an isotope of oxygen. So in beta minus decay, a proton changes into a neutron and a positron. So this is why the atomic number decreases by 1, because it has 1 less proton. Now finally, the last one is neutron emission. Neutron emission. Remember, emission just means if something's emitted, it just means it's given out. So my neutron is that. Remember, a neutron obviously has no protons and it has 1 neutron. So let's imagine if I was doing the neutron emission of this particular isotope of beryllium. So when this beryllium decays, it gives off 1 neutron. So again, I know that is my neutron. So again, the mass numbers need to add up. So something plus 1 is 13. So on top it's going to be 12. On the bottom, something plus 0 is 4. So it's going to be 4 on the bottom. Now, this time, because I haven't lost any protons at all, my atomic number stays the same. As a result, I still have beryllium. It's just a different isotope of beryllium. So remember, the key to all of these is if you know the particles, if you can remember these different particles, then you just need to make sure the mass numbers add up on both sides of the equation and the atomic numbers add up on both sides of the equation. The final thing that we need to know is this, because gamma rays can also be given out during nuclear decay. So gamma rays don't change the mass of the nucleus. That's because, if you remember, a gamma ray is simply a part of a wave from the electromagnetic spectrum. So it essentially has no mass. So when gamma rays are given off, it's just a way of getting rid of excess energy. So guys, that's everything we need to know about nuclear equations. Thank you.